Hello, friends. I'm Ashish Darbari, founder and CEO of Assam. To our new listeners, welcome, and to our old listeners, welcome back. Today in house, I have a very interesting person. I'm talking about Bipul Talukdar. He is Director of Application Engineering North America for SmartTV technology. Hi, Bipul. Welcome in house. How are you?
I'm good. Thank you, Assis. Thank you for having me here.
Oh, no, it's a pleasure to have you with all of these announcements on verification IP. But hey, before we get into verification IP and all of the interesting things that SmartDV does, let me focus on you a little bit, if I may. Where were you born? How did you get into science and engineering? How exactly did you end up doing interesting things with verification?
Right. Yeah. So I'm born in Assam, the northeastern state of
Uh-huh.
India, which is kind of bordering China, if you
Uh-huh.
had to geographically locate it in the globe.
I'll tell you, everybody knows Assam because everybody has drunk a cup of Assam tea. So
Right.
everybody knows where
Yeah.
Assam is. But yeah, it's just
So we
always
are
nice to, yeah.
largest supplier of tea. That's correct.
Sorry, carry on. Yeah.
Um, yeah, so growing up in Assam, I always wanted to be an electronics engineer. I say electronics engineer, not computer
Uh-huh.
science engineer. So that time, like electronics had like little more glam into it.
Mm-hmm.
Computer came
Mm-hmm.
in, a little more
Mm-hmm.
emphasized,
Mm-hmm.
later.
Mm-hmm.
Okay, right out of engineering studies, like I did my engineering in electronics and telecommunication from the National Institute of Technology in Silchar in
Uh-huh.
Assam,
I see. Yeah.
in the same state where I was born.
Mm-hmm.
And coming out of there, I was always looking for a job to do microprocessor-based system design.
Mm-hmm.
And the knowledge I had from engineering studies at that time was just 85 microprocessor from Intel.
Yeah.
That's way back, interesting stories around 85 I have.
Mm-hmm.
So it is very hard to get into, development job right away, which just fresh out of college at that time.
Mm-hmm.
And so I found a little firm who wanted to give me, development work based on 85.
Right.
So I worked on that records,
Hmm.
like 85 based
Yeah.
system design,
Yeah.
created, commissioned some systems, writing machine code programming and all that stuff.
Mm-hmm.
Yeah, so that's how my career started. And then after, eventually, I joined Cadence Design Systems in Noida.
I see. Mm-hmm.
Yeah, and that's where I got into verification, IP development, including assertion-based verification
Right.
in the work. So that time the war was on between SVI and PSL
Right.
as a language.
Uh-huh.
Yeah, and then in a deal, Cadence kind of lost zero into Metro Graphics, and so Cadence had to develop the assertion library. So I was tasked with that. So I wrote the first assertion library in PSL for Cadence that time. And
Nice.
then, based on that work and some more verification, IP work, I was hired by Mentor Graphics in the Silicon Valley.
Okay.
That's how I came into the States.
I see.
And
Mm-hmm.
that's how I was part of the verification IP development team in Mentor Graphics and worked in verification IP development, which is targeted for all different verification platforms.
I see. Yeah.
Simulation, formal,
Mm-hmm.
emulation. So I started developing a lot of interest in formal verification. Was engaged in benchmarking evaluation works for Questa Formal
I
that
see.
time.
I see.
And so that kind of work I got into. And then from there on, mostly I was working in assertion-based verification, working in checkerware libraries, QVL libraries from Mentor.
Right.
Um,
Mm-hmm.
yeah, and then
Interesting.
I was working for formal verification work for other companies like DE Shaw Research, and there I was working in formal verification for the so there they were building some supercomputer ASICs, and for that I was part of it, and that was a great learning experience, and also contributing to the cause there.
Right.
And from there on, I joined back Cadence again, working in formal verification. Primarily, I was owning some of the product engineering works for just for formal verification tool. And from there, I moved to Sci5, and that's where I was working in the advanced hardware design development flows, how verification can be improved on for catering to that kind of a flow. And with all that knowledge, then I decided to move into SmartDV and be part of the current revolution that we are working on at SmartDV.
This is very interesting. Quite an impressive journey through Cadence, Metro Graphics, Sci5, D-Shaw Research. So I now know if I want to blame any of the VIP issues in Cadence or Metro Graphics, I could come to you and blame you, yeah, given you were involved from the very beginning. But no, good to know all of that. So tell me, what is SmartTV doing these days? I hear that you guys are making almost all kinds of verification IP. Do you want to share with our listeners a bit more on the company profile? What do you guys do? What sort of product ranges do you make?
Right. So SmartDV was formed like back in 2007 by our founders. And the idea was to move kind of like a transactional business into kind of like a service-oriented business. Because if you look at in transactional business delivery model types, it really do not work, because what you develop and you provide to someone, it doesn't just right fit into the flow. There are a lot of work needed around it, a lot of support work needed around it. And that's the reason why there was this model of service-oriented business for verification IP and design IP. Like I said, that it needs customization. It needs customization to verification IP and design IP to fit a specific flow for a specific project worked by somebody who is developing this new, SoCs, cores, or any hardware block for that matter. So we are about 250 experienced ASIC and SoC design verification engineers. And we believe that that's a good amount of investment in number of engineers, the manpower, the resource for developing just doing verification IP.
So I have a quick question, Bipul, if I may ask you. You mentioned something about going service-oriented along with verification IP. The whole point of having a verification IP in the first place is to provide the automation so that you take the heavy lifting out of human effort. So why would you then need more service engineers to get the verification IP in the hands of the end customer?
Right. So when I say service, I also mean deployment and to make a verification IP successful in the flow. So whenever a verification IP comes from a third party, the understanding its architecture, understanding how it fits into the existing pieces in-house, is a big effort normally you put in. And that's the reason why, the companies, they do not like to move from a verification IP one kind to another, because there is a effort involved going from here to there. And that's where we come in very handy, because we do the heavy lifting of kind of integrating a verification IP into any target environment.
I see.
That's how we are successful to be able to replace what is out there or just deploy for a new fresh flow.
So another question then. So is most of your business then service oriented, or most of it is product oriented, with services being almost supplementary as it was?
That is correct. So this service that I mentioned is come with our product. We are a product company the first place. But I mentioned service oriented so that, because we have seen from our experience that is required together with the product that someone processes. The support is a big deal here. Take a piece of design IP and it comes with a huge manual. Nobody had the time today to read through the entire manual, the user guide, and to make things work. And that's the last thing an engineer do, what I have seen from my experience. They do not read the user guide. And somebody handy to talk to, somebody handy to work together, shoulder to shoulder, and that's what we are. That's how we make things more productive.
I see. So tell me a little bit more specifically on the kinds of key technology challenges that you are overcoming with your solution. I mean, are you building a lot of ARM-based VIP components? Is that what your focus point is, or is it HDMI? Where are your main strengths, and where do you see the market going in which particular technologies?
So our breadth of protocol expertise is so much that we do not really center around one piece of protocol, like be it HDMI or be it just architecture or RISC-V as an architecture. To explain why I say that, I have to tell you a little bit about our technology. So our design flow or development flow is centered around our smart compiler.
I see.
So we developed long time back, and when it was founded, we developed this smart compiler, which is highly parameterizable, and it has its own language that you can enter a specific protocol at a higher level of abstraction.
I see.
And that supports a lot of parameterization. So given that, basically we can encode a protocol in our language at the higher level of abstraction, and once it goes into the compiler, you can just speak what you want to generate. You want to pick BFM for a specific protocol. Right. Once you have entered that protocol in our proprietary language, then you can produce anything industry standard language based or methodology based.
I see.
Components. Okay. And that's applicable for both verification IP and design IP. And that's our the secret sauce. That's how we can with these many engineers we can produce today more than 600 products in the market. Name a protocol, we most probably have it.
I see.
We have the largest portfolio of verification IP and design IP today.
So I don't know if this is secret information, but which ones of these 600 ones are you selling the most? Where are you seeing the market trends going towards? Is it in SoC-based verification IP, or is it the design IP that's actually taking most of your business forward?
Right. So we see a big trend in terms of, say, RISC-V, for example. It's not still as large as what is the existing, ARM-based architecture-related protocol-based, products. But still, the RISC-V is gaining a huge momentum.
Oh yeah. Yes. Right. Yeah.
So that's how we came up with our RISC-V based solutions, be it bus functional models or be it a CPU verification flow.
I see.
We came up with all that. We have enhanced our compiler to be able to cater to that need.
Okay.
And so that's number one. Then we have lot of in the video products, like you mentioned already, HDMI related display. Then memory related, memory models related. We see a lot of trend coming in there, LPDDR4, 5. There is a lot of trend towards that.
Right.
Yeah, and also we see a lot of trend towards FPGA-based, verification IP requirement. Given this IoT business that's so much growing today, processors are being picked from probably open source sometimes. They pick the processors and they build specialized, so maybe coprocessor, maybe accelerator and things like that. And those can be verified on a piece of FPGA, and we are big in an FPGA. Our the flow, the way we do our flows is very easily we can move our verification IP from platform to platform, be it from simulation to emulation or FPGA. We can do all that.
That was my question. That is what I was That is what I was going to ask you. Is that your VIP components are reusable, but potentially going from a simulation-based bus functional model, you probably want a synthesizable VIP for emulation and FPGA. So are you then focusing more on assertion-based modeling style to make everything synthesizable? I mean, how do you take a simulation-based VIP from a simulation environment into an emulation or an FPGA?
So as I already mentioned about our smart compiler, it's very easy for us to produce synthesizable code.
I see.
And the smart compiler is ruled by very uniform linting methods, like advanced. And so whenever you produce code, it's already lint free. You don't need to lint again,
Okay.
because it's adhered to certain strict rules
Right.
already as part of it, and it's uniform code. It's not like n number of engineers developing different products at different level of efficiency of the code. It's uniform efficient code. So, and we can also create synthesizable code, the BFM synthesizable. It's very easy for us to crank out. And once we have those cranked out, then all we need to create is the usage interfaces, right? I mean, once you have the VFM on the hardware, then the usage interface, we prefer to do through DPI because it's more of like a universal. And to do the user interface related works, like you might like to have your test bench on a host machine and work through DPI to the hardware where your hardware is running. Or if you want your test bench itself is synthesizable, that's also not a big deal for us because we can produce test bench also as synthesizable component. It can just everything just go onto your emulator or FPGA, and this is pretty easy for us because of the way we do the flows.
So Bipul, I have a question. So you're selling simulation-based VIP, formal VIP, targeting emulators and FPGA. Where are you seeing the most amount of pull from? Is it from the simulation-based customers, or formal verification, or emulation, or FPGA? How do you see the scattering?
I see a bigger trend towards FPGA today. I think
makes sense,
users have realized that there is a money factor involved in the emulation, because you have to buy huge machines, and of course there are like cloud-based emulation today available out there, but people get nervous talking of cloud in emulation cloud and all that. So FPGA is pretty handy. Only thing is that you need some in-house experts to work with the FPGA, and it's low cost and it's scalable. So all that advantages, I think, is valid to say, because I see that trend already towards that.
So what do you notice about the simulation-based verification?
I think it's the standard, right? It's out there. I mean, there is nothing new about it. It's simulation. It has its limitation in terms of how deep you can go. So you have formal to complement it, and then how much breadth on simulation, how many cycles you can do within limited amount of time. To complement that, you need emulation, and even not to just complement. Maybe it's a necessity for bigger chips today. Emulation and FPGA, both of these. I mean, I have seen people doing no emulation, just FPGA right from simulation.
So I can see the value in emulation and FPGA. That's hardly difficult to understand. But if you were building chips for IoT, small microcontroller-based IP components, would you still see that your customers are using emulation for that kind of verification? Would they not use a combination of simulation, formal, and then FPGA-based testing?
Right. So depending on the complexity level, probably, and depending on the application, because if the application is less critical, maybe you don't have to invest in formal. Just go from simulation to FPGA. But I think that FPGA is a must if you are tapping out to safeguard against that, or maybe you are developing products for just FPGA. Of course, in that case, it's essential.
I see. Very interesting. So in terms of the VIP components that you're building, are you also having solutions for networking products then? And what kind of networking protocols do you support?
I think we support pretty much what's out there. For all flavors of Ethernets, of course, we have it, and we have not just VIP. We have design IPs all around that.
What about Wi-Fi? Wi-Fi based?
So Wi-Fi is something we thought of touching it. It's a good point that you brought it up. And there were several, I think it was primarily like, it's not like a feasibility question, we could do it, but Wi-Fi, mostly what we have seen is that whoever are doing it, they like to do stuff themselves because of the specialty brought into the products.
I see.
And so we have seen like not much a benefit going just do Wi-Fi. Instead, we steered our resources to do something else which is more beneficial for us. But it is something, if someone wants a Wi-Fi product from us, we can work with them if they need it. It's pretty not so hard for us to do, but we haven't put out there.
What about 5G then? That's the hottest topic right now. Are you seeing a lot of application of VIPs for 5G design verification?
As we have seen a trend, asking for products around that, and I cannot, of course, mention who are asking and what is being asked exactly. But we are, investing ourselves in that regards.
I see. Awesome. Okay, so Bipul, if a listener today wanted to take away 5 tips to pursue a career in verification, I think you would be really appropriate to take these tips from, given your journey into all kinds of verification work that you've been doing. What would be your recommendation, especially to the new, fresh engineers coming out of the university? What should they do to carve out a successful career in verification?
Right. Okay. So my first tip would be it's a dynamic market, and it's very hard to know exactly where the market is going, but you can follow the market just by reading the job descriptions. It always works. And there will be, some companies may not write everything in the job description because of confidentiality, what they're working on. But 90% of the time, you cannot go wrong with the job descriptions.
Right. So you're saying follow the market trends, and then where you think most of the jobs are, that could be a good indicator of where you could focus on. Yeah, that's a good one. Yeah. Second tip.
Right. and there is no replacement of keeping up to date, reading tech journals and attending conferences. And so I would strongly advise everyone to go to tech conferences, and that's where the icing on the cake is available.
Yeah, that's right. That's again, I totally agree with that.
And number 3, I would say, being a verification engineer and a developer for verification solutions, I would still say that innovation is lacking in verification today. So there is lately there is a lot of design flow related advancement. You might have heard in the RISC-V world, at least, that where people write things in language like Shell, BlueStack, and then produce the hardware. Now you produce hardware. Now how do you produce the verification component to fit into that advanced flow? So we need innovation. This is just an example. We need advanced verification components. Be an out-of-the-box thinker. Bring in fresh ideas. Do not just go by what's out there. That's important. That will be my 3rd point.
Yeah. Couldn't disagree with that. Yeah, absolutely 100% right. Yeah.
And the 4th one, I would say, believe in symbiosis. The symbiosis is very important. Be part of open source community, contribute and digest what's out there. And once you contribute, your work is seen out there, getting a job, getting opportunities, working together with bright people all around the globe will not be very hard. It's very, and also helping the fellow engineers on continuous basis, being part of open source community, I think is a noble thing to do.
Yeah, absolutely. And the last one.
All right, the last one is get involved. Make your hands dirty. It's very important. Ask questions to the experts, even if you think it's a stupid question. A question always opens something like a new possibility. People can say some question is stupid because there is
no
concept around that. But our idea is to innovate, getting involved. So that's what I would say.
Excellent. Totally agree with everything you said, Bipul. Thank you so much for coming over as a guest. I'm indeed very thankful and grateful to you. And I very much look forward to getting you back as a guest. Thank you very much.
Thank you, Astis. It was a pleasure. Thank you.
So, friends, I hope you enjoyed our chat today. It is not easy to find experts who have this breadth of knowledge from design to verification. And Bipul gave excellent 5 tips to everyone, especially the younger generation who's listening to us. So keep following us, subscribe to our YouTube channel, email us at info@aximize.com, and we will be back next week. Stay healthy, stay connected.